Okay, once again, just looking for answers. This is a tendon. I believe it's a human tendon, and this is the tendon itself, and the strap comes down through a little Chinese finger trap, and that ball is the enthesis point, which is the anchor that anchors tendons to bones and things. Now, that ball should be inserted into a tuberosity, which is a hole in the bone, and it's not. So that's not, it should be in a bone. Now, this right here is, all the world looks like it has the same architecture. Now, another thing I forgot to mention was, you see up here, way up in the back here, that is what they call small leucine-rich proteins, and it's a gushy mat that surrounds and lets these tendons slide through it. It's just the way it works. Now, this is a double. I'm saying, I don't know what it is. All I'm saying is this is olivine and plagioclasis. And it has the exact same architecture as the tendon mat, enthesis point. I cut the ball off. It was as round as a baseball. And then there's another one on top that would have slid this way. Just as you could see in the other one, they were side by side. This was apparently laying sideways or something of that nature. Now, this, as you can see, is that plagioclase material. The white is plagioclase, moisture there, and the green, I suspect, is olivine, and these need to be tested, but I'm pretty sure that's what it is. This outside rind is that fibrous fascia material, and it's the fascia is different in all different organs and different places in the body. There's 20 different types of fascia. Some of them protect caustic, some of them protect and so forth. But anyway, this doesn't have the same structure as the lung, but it is fascia, and it's very clearly under the microscope you can see that it's a fibrous matty material. This again is that Slurpies, the SLRPs, and that's what allows these tendons to slide one against the other. That's all I can say. And again, if you have some other explanation for this particular formation and these particular chemicals coming together in these particular ways, I'd certainly like to hear it. But I mean, that is the life process would create this exact architecture, this exact compilation. I mean, they're not, you know, in your body there's no olivine, but you know, that's what it breaks down to. And I believe this is either nucleophilic reaction or just ionic reactions that turn the chemicals of life into stone. That's all I can say. I'd love to hear some other opinions. All right, this is some of that Slurpy material from I believe, again, I could be wrong, but I believe it's another tendon complex. And this is the Slurpy that was in between the tendons when they split apart. Just like that other one that came apart. And I'm going to show you what that looks like under the microscope too. This is the Slurpy that was between the first complex that I showed you with the two pieces that split apart. And this is very black, and it certainly can be tested for the chemicals that would sublimate to create this, and this type, any kind of blood or any of these tissues, it's a transitional progress that they start to break down, and the volatile organics gas off and sublimate, and it condenses down until you get down to this black stuff. The other one was still red because it was virtually not decomposed completely at this point. This is the rock that I just showed the red Slurpy on. That's it right there. Now, right there is a plagioclase that dives in and anchors. And here is some plagioclase that has been eroded by some kind of chemical interaction that eroded away the olivine and left the plagioclase. And there's other ones in here too. And that is a blood supply of some sort in these mud fossils that is a vein or an artery, probably an artery because it's been expunged, completely cleaned out. Sometimes the veins will remain with some blood in them, but you get these fan structures, and this is because it's a wet environment and the contents of the veins and so, I mean the arteries and sometimes the veins are washed away, and then they propagate crystals within those cavities. That's what if there's other reasons, I would certainly be interested in hearing it. Now, when I say other reasons, I know people are going to say, oh, well, that's a plagioclase, and this is olivine, and that is something else, and so forth. I know that's the names they gave them, but what is the process that put all these things in a form that is predicted if it was life? It's exactly what you would get if it was life, and I can't think, that didn't recrystallize in that form. I can't think of any possible way that that could have done what recrystallization says it does. It just doesn't make sense to me.